Hello and welcome to yet another module on population studies. Today we are discussing population, climate and health. Global climate change will have important implications for human population health. It is one of the emerging set of global environmental changes that are already affecting human population health and will increasingly do so in the future. Climate change does not exist as a separate single exposure, but consists of a range of exposures that are relevant for human health. Climate change will exacerbate many of the current important environmental determinants of disease. Some climate and weather factors act directly and are relatively well understood, such as the health effects of heat waves or the physical and mental consequences of floods. Other health effects are mediated by climate sensitive biological processes such as changes in infectious disease transmission or crop yields. Climate is ultimately the determinant of food and water availability and the distribution of vector-borne diseases. Climate related decreases in food and water supplies are potentially responsible for the largest future burden of diseases due to climate change. But such impacts are also the most uncertain to foresee because they are contingent on future social, economic, political and population factors. There is now a wealth of evidence regarding changes in climate and environment due to anthropogenic climate change. The Intergovernmental Panel on Climate Change published its fourth assessment report in 2007, which included a global assessment on the impacts of climate change on human health. Food and malnutrition. Hunger and malnutrition are widespread, and it is anticipated that climate change will exacerbate this by further reducing global food security. Presently, there are close to 1 billion people with insufficient calorie intake, and 1/3 of the burden of disease in young children is attributable to malnutrition. Future impacts will depend on the trajectories of a number of factors, including the magnitude of climate change, the size of the population, their income levels and the environment in which they live, as well as technological developments in agriculture. While climate change is likely to affect crop productivity, food security and the relationship between food and health is governed by many factors. The key determinants are availability, the adequacy of food production and supply, stability, that is the consistency of these food supplies over time, accessibility, that is the accessibility of food to the population at large, and utility, that is the health of those consuming the food and their ability to benefit from the energy and nutrients in the food they consume. Compromising any of these elements could lead to increased level of malnutrition and poor health. Future change in mean climate, extreme weather events and population size and distribution are likely to impact on each of them. However, modeling the elements of food security simultaneously is difficult, and to date no quantitative studies have taken account of all of them. Consequently, assessment of future hunger and malnutrition only capture a part of the picture despite the use of specific and plausible climate and population scenarios. A number of studies have modeled crop productivity, that is addressed availability under various climate and population scenarios, and two recent papers illustrate the potential threat posed to populations with already high levels of malnutrition. Used statistical models for a range of crops grown in 12 food insecure regions to estimate productivity in 2030. They found that in the near future, changes in the temperature and rainfall are likely to reduce the crop yields of various food sources, particularly in South Asia and Southern Africa, look to the end of the 21st century and suggest that by that time there is 90% probability that growing season temperature will exceed even the most extreme temperatures seen during 1900s to 2006. This could severely reduce crop productivity and many place 3 billion people, most of whom depend on agriculture for their livelihood, at risk. The areas expected to be most affected are tropical and subtropical Africa and Asia, and parts of South, Central and North America and the Middle East. Where food is grown, availability may not be where it is consumed, that is the access. The global trade in food is a determinant of access and relates to cost and the ability of populations to purchase food, while climate change is estimated to increase the population at risk of hunger due to reduced crop productivity. Socioeconomic factors will have a far greater impact. In scenarios in which population growth is decreasing and there is a strong economic growth, the models suggest that hunger could decrease by more than 75% from the current levels by 2080. In addition, driven almost entirely by socio-economic factors but contingent on assumptions made within scenarios, the region with the greatest number of hungry people is expected to shift from South Asia to Sub-Saharan Africa by 2080s. Of course, despite their relative importance, development pathways will not occur independently of climate change. Increases in wealth, narrowly defined, could come at the expense of significantly increased greenhouse gas emissions, which would result in greater impacts of climate change on food production. None of the above studies include impacts of extreme weather events such as droughts or surprise events such as pest invasions. Hence, the impact of climate change, which has the potential to increase both of these, could be reasonably expected to be greater than the models suggest. Furthermore, the effects of a lack of food are magnified by other factors such as diarrhea prevalence. If a population lacks improved water sources and sanitation, which result in high rates of diarrhea, there will be more malnutrition associated with a given level of food consumption. A multi-country analysis found that approximately a quarter of malnutrition in children aged 2 could be attributed to having had 5 or more episodes of diarrhea. Overall, future hunger and malnutrition will be driven by a range of influences, which will in turn be related to both climate and population changes. Other factors such as governance that ensures equitable access to food will be critical. Now, water and health. Climate is a key determinant of water availability. Surface water availability depends on the timing and volume of precipitation. The current burden of disease as a result of inadequate access to improved water sources and sanitation has long been recognized, particularly the very high rates of infant mortality in deprived urban areas. There are clear social and economic reasons for the lack of access to improved water at the household level. However, populations in both high and low income countries have experienced failures in supply due to extreme droughts. It is also known that access to water is not equally distributed within cities, and any reductions in supply are likely to have a greater impact on impoverished populations. Climate impact assessments are often conducted at the river catchment level and converted to water availability per capita or withdrawal to resource ratio. Such indicators are useful to some extent, but they provide no information on the level of access to water, the quality of water, or any differences between rural or urban areas. Climate change is likely to cause a decline in environmental water resource availability in certain areas where water resource management is poor or non-existent. This will have a negative impact on water availability at the household level. The impact of climate change on water availability is likely to be one of the most significant for the health of the populations. However, due to the complexity of the factors that determine access to clean water, that is social, political or environmental, the impacts on the health are not well addressed in the climate impacts literature. Although disease rates can be reduced very cost effectively by improvements in hygiene behavior, such improvements require access to sufficient quantities of water. In one study, interventions to improve water quality failed to deliver a significant reduction in the diarrheal diseases in places where water availability was limited. As discussed below, heavy rainfall and flooding are also important issues for environmental health in urban areas. Emerging infectious disease. Many infectious diseases of animals, humans and plants will be affected by climate change, and diseases transmitted by cold-blooded vectors will be the most susceptible to climate effects. According to United Kingdom Foresight review, future expectations of infectious disease are based on an understanding that the majority of emerging and re-emerging human infectious diseases originate in animal sources. Since these animals are likely to face continued incursions into their natural habitat, trade for meat and exotic commodities, as well as their presence as pets, the trend of one or two new human pathogens identified each year is expected to persist. Climate change impacts should therefore also be seen in the context of these other important drivers of the emergence of infectious disease and the large changes that are already occurring. The global burden of vector-borne diseases, especially malaria, remain high. Climate factors affect both malaria carrying mosquito vectors and malaria parasite development rates. Although the overall impact of climate change is uncertain, it is likely to facilitate vector expansion to higher altitudes in highland areas surrounded by endemic transmission. The East African highlands are densely populated and therefore potentially at an increased risk of malaria due to climate warming. Malaria epidemics are of particular concern as they occur in populations that lack partial or full immunity to the disease and thus experience high mortality rates across all age groups. Example of evidence for climate effects on other infectious diseases include meningitis. Occurrence in the Sahelian dry season is associated with increases in temperature and decreases in humidity and is related to dust. Epidemics occur in environmentally suitable districts during the dry season and end with the first rains. There is a moderately strong relationship between climate and the outbreaks of meningitis that is not well understood. Cholera. Outbreaks are associated with increases in sea surface temperatures in addition to poor sanitation and hygiene behavior. The association between climate and cholera outbreaks is strong in the coastal region of Bangladesh. Rift Valley fever. Epidemics, animal and human, are related to short-term increases in the rainfall. Cold weather is associated with the end of the epidemics. Rift Valley fever is moderately sensitive to climate variability. Leishmaniasis is associated with an increase in temperature and rainfall. Outbreaks of leishmaniasis show a moderate variability based on climate. Although vector-borne diseases are strongly affected by rainfall and temperature, which can trigger outbreaks, the longer-term impacts on these diseases due to climate change is less clear. The effects will depend on the current distribution of the disease. Many diseases are well within the climate limits, and the capacity of the countries to control the infection over the next decades. Flooding and disasters. Now, flooding and tropical cyclones are the most common natural disasters, accounting for 40% of the 1062 recorded disasters between 2004 and 2008. Each year, around 120 million people are exposed to tropical cyclones and storm surges, which caused an estimated 250,000 deaths between 1980 and 2000. Single events can be devastating. In Bangladesh, tropical cyclones in 1970 and 1991 caused 3 lakh and 1,40,000 deaths respectively. The impacts of an event, however, is greatly modified by population vulnerability. For example, similar number of people are exposed to tropical cyclones in Japan and Philippines each year, that is 22.5 million and 16 million respectively, but the death toll in the Philippines is 17 times higher than that of Japan. Considering low income countries as a group, the relative mortality risk is close to 200 times higher than in the countries of the Organization for Economic Cooperation and Development. These figures highlight the influence of both climate and population factors on health impacts. Future trajectories of the population at risk of flooding have been developed using a global coastal flood model. The model was run for the climate and socio-economic scenarios developed by the IPCC for the special report on emissions scenarios. When socio-economic scenarios for a world with declining population growth and robust economic development are considered without climate change, the number at risk of flooding increase until the 2020s and then decline significantly by 2080s. The initial increase in the numbers at risk is driven by the model's assumption that coastal populations will grow at twice the rate of the whole population, and that while increasing wealth will lead to improved flood defenses, the time it takes to build new coastal defenses is approximately 30 years. In socio-economic scenarios with high population growth and lower economic growth, the numbers at risk of flooding continue to rise beyond the 2080s. When sea level rise due to climate change is included in the model, significant additional impacts are not evident until the 2080s, when, depending on the scenario used, between 2 and 50 million additional people are estimated to be at risk. The model does not account for the possibility of an increase in the frequency and the intensity of tropical cyclones and storm surges, which have the potential to greatly increase flood risk attributable to climate change. Overall, the model suggests that the population size, the area in which they live, their wealth in terms of ability to build flood defenses, and the increased risk of flooding attributable to climate change will be all critical determinants of future flood risk. Now, heat waves. An increase in heat waves is one of the most certain impacts of climate change. All populations are affected by extremes of temperatures. Epidemiological studies have mostly been undertaken in the populations in temperate climates where mortality is shown to increase in hot and cold weather. Heat mortality risk varies by age and with other social and environmental factors. The majority of European studies have shown that women are more at risk of dying in a heat wave. There may be some physiological reasons for an increased risk in elderly women, but social factors are also important. Elderly men are more at risk from heat waves than women in United States, and this was particularly apparent in Chicago heat wave in 1995. In addition to the natural patterns of aging or senescence on homeostatic mechanisms, several medical conditions increase vulnerability to heat stress. Many deaths that are attributed to heat do not result from heat stroke or are even in persons that exhibit the clinical signs of heat stress. It is likely that there are several mechanisms by which a person may succumb during a heat wave, as the environmental temperature places extra strain on the body. If the exposure to heat wave is severe enough, even healthy people will succumb to heat stroke. Climate change is likely to increase the number of heat related deaths in temperate populations. Less is known about the heat effects in tropical or subtropical regions. A main uncertainty in estimating the future impact of climate change on heat related mortality is the extent to which, even without specific adaptation strategies, physiological adaptation and factors such as behavioral changes in hot weather will reduce impacts in the general population. Physiological acclimatization to hot environments can occur over a few days, and this can explain why the impact of the first heat wave on mortality is often greater than that of subsequent heat waves during a single summer. The rate at which infrastructural changes will take place is likely to be much slower. Neither the magnitude nor the time course of the various modifying factors can be predicted with any confidence. It is clear that preventive measures will be needed to counter the substantial initial adverse effect of heat, and long-term changes are required in the housing and urban infrastructure. Now the conclusion. Protecting and improving human population health requires new research on climate health links as well as improved methods to guide adaptation strategies. To identify future health threats, the population likely to be affected by them, epidemiological methods and modeling strategies which have conventionally focused on less complex risk outcome structures need to be further developed and in particular applied in low income settings. In order for such research to be used to develop policy, it should where possible specifically consider the influence of socio-economic and demographic factors. It is often possible to include these when assessing the past and the present. However, when considering future impacts, the application of such finding is difficult as quantitative description of plausible future socio-economic and demographic conditions are generally limited to GDP and to population in terms of numbers and age stratification. Means to overcome these limitations include the development of scenarios with more detailed quantitative descriptions of plausible future worlds and the modifications of methods for assessing the means of adaptation in the face of particular health threats. Additionally, methods of assessing and characterizing uncertainties in health assessments need to be further developed and should focus particularly on ensuring that the characterization is useful to policy makers. Given that many adaptation strategies have long lead times, it is critical to ensure that the uncertainties inherent in the still developing field of climate health research do not prevent appropriate actions from being taken. Climate change is a unique health threat in that it will affect all populations and requires consideration of extended time frames. In the near term, many of the mechanisms by which health will be affected are known, although the magnitude of the impacts and the effectiveness of the prevention are highly uncertain. There are likely to be many changes that are unanticipated involving ecological shifts or emerging infections. Under the higher projections of warming, more than 2 to 3 degrees Celsius above pre-industrial climate, the uncertainty is greatly increased. This rate of change is unprecedented for humans and has unknown implications. Thank you so much for watching.